All right. So we left off yesterday. We talked about combining functions together, add, subtract, multiply, or divide. And today we are going to do the other half of this lesson, composing functions. Composing functions is where you plug a function into another function. So some of this will look like substitution that we did back with our system of equations in an earlier section. There are two different ways you're going to see composition written, either with an open circle between the names of the function, and then you will see closed circle problems as well in this section. That means multiplication. So it's easy to get those two mixed up. So closed circle multiplication, open circle composition. Or you're going to see it written like this. I personally like this one better, the one on the right, because we're plugging a function into another function. And I think it's easier in this second notation to see that you are plugging g into f. Do you see how function g is inside function f in that notation? So a lot of times when I will see this one with the open circle, I will write it like this instead with the double parentheses, because then I can see what's inside of what I need to plug into something else. All right, so just like yesterday, we're going to start with some ones where there's a number there already, and this is below that on your paper. So again, instead of the open circle, I'm going to rewrite it with the double parentheses. F of g of 2 is how I would read this. Either way, and with the double parentheses, it's going to look like f of g of 2. When we evaluate these, think about what you would do in the order of operations if you have two sets of parentheses. You would work from the inside out. We're doing the same thing here with function notation. So I'm going to start with what's on the inside, g of 2. So g of 2 means plug 2 into g, and that's probably something you can do in your head. If you plug 2 into g, what would you get out? 2 squared plus 4. Do we need to write that out? G of 2, 2 squared plus 4, thank you, is 8. Okay, so that whole inner parentheses, g of 2, is equal to 8. So I can replace it with 8. Now look what we have left, f of 8. So that's our second step. We're going to plug 8 into function f. So f of 8 would look like 5 times 8 minus 6. Again, maybe something you can do in your head. What do you get? 34. Make sense? Okay, let's try the next one. G of f of negative 5. Again, I'm going to write it like this. G of f of negative 5. So what am I plugging into where first here? What's my first step? Negative 5 into f. Okay, and again, maybe you can do that in your head or do it in your calculator. If I plug negative 5 into f, it would be 5 times negative 5, which is negative 25, minus 6 is negative 31. F of negative 5 simplifies to negative 31. And now I need to plug negative 31 into g, and I agree we probably need a calculator for that one. So we're going to do negative 31 squared. Remember, that should be a positive number if you're doing it right. Plus 4. And you should get 965. 31 squared is 961 plus 4. All right, questions evaluating with composition. Pretty quick little questions. You just have to work with the notation. Okay, on your paper, flip it back over now to the one we were doing yesterday that had the graph on it. This guy. Okay, same graph. And these three were at the bottom that we did not complete yet. And that's because they have the composition. So I'm going to rewrite the first one, f of g of negative 1, with my double parentheses, f of g of negative 1. Ignore the beep. Okay, so just like the last problems, working from the inside out. G of negative 1. All right, so negative 1, remember, is an input. It's an x. So x is negative 1. What does g of negative 1 evaluate to in this picture? Good. You have to go up to the purple graph on 9, which goes up to 1. So that innermost parentheses simplifies to 1. Now we're going to evaluate f of 1. So now I'm going to start where x is 1. And I want to find that point on function f, which is the blue one. And actually, if I'm on the x-axis at 1, I'm on function f. I'm touching it right now. So my answer is 0. I don't have to go up or down at all. Okay, go ahead and try the next two. Give you a minute. Try them on your own and then check with a partner. All right. 0 and -1 look good. Okay, so we get 2 for the first one and then 0, 3 for the second one, -1. Any questions evaluating those with the graph? All right. So that's all the evaluating problems. Flip your paper back over. Let's do the actual composing problem. So let's say we do not have a number for x now. We just have the function. And we are literally going to plug one function into another function. This problem has 4 parts. They are listed at the top. We're going to do g of f, f of g, f of f, and g of g. So I'm going to start with g of f. And again, I like it written like this with the double parentheses instead of the open circle. Okay, so what am I plugging into what there? Am I plugging g into f or f into g? This means f into g. Here's how we do that. We're going to take all of function f, circle it. We're going to put it into function g anywhere where there is a variable. We're going to take the variable out and replace it with function f. If there are multiple variables, you're plugging it in multiple places. Function g only has one x. So we're going to take that x out and we're going to put 2x squared plus 3x in its place. That looks like 2 parentheses 2x squared plus 3x, end my parentheses, -1. And then we simplify. What can I do to simplify this? Just distribute, yep. 4x squared plus 6x minus 1, and your answer, just like yesterday, is going to be a new function. This is our new function, function g of f. We are not solving it, okay? Just expanding it as much as possible. Let's do the next one. Letter B is f of g. So, all right, f of g of x. What are we plugging in? What into what? G into f. All right, if I plug g into f, I'm going to circle function g. And function f has 2 variables, so there are going to be 2 different places where I'm going to put that 2x minus 1. X is coming out, 2x minus 1 is going in its place. That looks like 2 parentheses 2x minus 1 squared plus 3 parentheses 2x minus 1. All right, so that's my composition. Now I just need to simplify my answer. Remember, if you have foiling and distributing, you always FOIL first. So we're going to FOIL out 2x minus 1 squared. Hopefully you can do that in your head. First terms are going to give me what? 4x squared. Outside terms will be a negative 2x. Inside terms will also be a negative 2x, negative 4x. And then my last terms, positive 1. Plus 3 times 2x minus 1. Then we distribute 8x squared minus 8x plus 2 plus 6x minus 3. And then last but not least, add up any like terms. So 8x squared minus 2x minus 1. Final answer. Okay. Letter C is f of f. Okay, and I can write it the other way, but it doesn't really make it any more obvious. We're plugging f into itself. is what this means. F into itself. So what does that look like? That means that everywhere I see a variable in F, I'm going to take that variable out and I'm going to put the whole equation for F in its place. So what you can do first to kind of set this up, because sometimes it's hard to visualize, is write function F without the variable. Just put some parentheses there, anywhere you see a variable. Okay, so I took my variable out, and anywhere we have that variable, write all of function F in there. 2x squared plus 3x, 2x squared plus 3x. Okay, and now we simplify, same steps as the last one. FOIL, distribute, combine like terms. If I FOIL, my first terms are going to give me a 4x to the fourth. My outside terms will be a 6x to the third. My inside terms will be a 6x to the third, so 12x to the third. Last terms, 3x and 3x, 9x squared. Plus 3, 2x squared plus 3x. Combine my like term, actually before I do that, distribute. 8x to the fourth plus 24x to the third plus 18x squared plus 6x squared plus 9x. All my distributing. And now I can combine my like terms. I've got a couple x squareds I can put together. Final answer will be 8x to the fourth, 24x to the third, 24x squared, 9x. Last but not least, g of g, which means plug g into itself. So again, try writing function g without the variable. Take the x out, so 2, leave a little bit of space where my variable is, minus 1. And then in the place where my variable was, I'm going to put all of function g, 2x minus 1. 2x minus 1 into itself. This one's a little bit easier to simplify. You can distribute 4x minus 2 minus 1, and the final answer then is 4x minus 3. Okay. Do you guys remember doing this in Algebra 2? Is this looking familiar? Hopefully. Should have done this before. Back to the domains. Domains are going to be similar to the ones from yesterday. We want to look at the original problems first. The original function f and g, do those have any domain restrictions? Any denominators, any square roots? No. So the domain of f and g is all real numbers. Do any of my other problems there have any domain restrictions with zeros in the denominator or square roots? So nothing up here has a domain restriction. So the domain of everything in this problem, and you can label it with all of them if you want, is all real numbers, negative infinity to positive infinity. Nowhere there do I have a restriction. Okay? All right. Why don't you guys maybe find your group that you normally work with, if you're close to them, that would be great, and try these 4. Don't worry about the domains, we'll put those up together later. Just go ahead and do the 4 compositions that are listed on your paper, okay? I'll give you a few minutes. Go ahead, find your groups, get together, move the desks if you want. Go ahead. All right. All right, so letter A, you can write it with double parentheses if you want. You're plugging f into g, which looks like this. In the first step, the square root and the square cancel, then the 3's cancel, and you are left with x. The opposite way, if you plug g into f, it looks like this. You actually don't need the parentheses here because there's nothing to distribute or FOIL. So the first thing you can do is cancel those 3's, and then the square root of x squared, the square root and squared cancel. You are also left with x on that one. Letter C is not really a whole lot that you guys can do as far as simplifying this goes. So this is pretty much what it looks like. Plug it in, and then you don't have to go much further than that. G G into G, you do have a little bit of FOILing. Make sure that first parentheses is squared. FOIL it out, you get those three terms. And then all I did in that last step was add the like terms together tonight. Questions on those four? Okay, let's go back and put domain question. Go ahead, yeah.
I was just gonna ask about the domain.
We're gonna do that right now. Perfect timing. Okay, so to talk about domain, we need to first look at the domains of the original functions. Does function f have restrictions? There's a square root, so yes. So let's review here how to find domain if you have a square root. Whatever's underneath your square root, x minus 3 in this case, we're going to set it greater than or equal to 0 because it can only be 0 or a positive number under there. So x must be greater than or equal to 3. And I'm just going to leave it like that for right now. We'll put the answers at the bottom in interval notation. Okay, so I have to only have values greater than or equal to 3. Does G have any restrictions? G does not have any restrictions. Any of the compositions that use F now will only have domains greater than or equal to 3, with maybe more restrictions than that. If it doesn't use F, we don't have to worry about that restriction. So like letter A here, my answer was X. X doesn't have any restrictions, but we used function F to get that answer. So my domain is the same as that of function F, which is 3 to infinity, 3 with a bracket, infinity with a parentheses, if we put that in interval notation. Letter B is going to be the same thing. 3 with a bracket to infinity, because that was the domain of function f. Letter C is a little tricky. It's kind of hard to explain how you would solve for this, so let me put it this way. It's going to have more restrictions than 3. For example, if I put 4 in here, 4 minus 3 would give me 1. Square root of 1 is 1. But then if I subtract 3 from that, I would have a negative. So 4 doesn't work. 5 doesn't work. 6 doesn't work. What's the first integer that you could plug in here that would work as you go up? What is it? 12 would work. If I do 12 minus 3, what do I get? 9. Square root of 9 is 3. 3 minus 3 would give me 0, which would be the first possible value. So the domain of this one is 12 to infinity, because that is the first number that would give me an answer that wouldn't be undefined. Function G, G into G. Does this have any restrictions? And I only use G to get it. Did G have any restrictions? No. So what's our answer for that last one? All real numbers. Negative infinity, positive infinity. Good. So those get a little tricky with the domains. Questions on those? Okay. Last slide on your paper is what we call decomposing functions. Now, when you guys do these in MathXL, one of the answers will be given to you and you'll just be finding the other one. How they're written right now is there's going to be lots of possible answers. When we decompose a function, we're looking for, this is the answer. This is what was plugged, after one function was plugged into another, this is what we got. When we're decomposing, we're looking for what were those two original functions. What could I plug into what to get this as an answer? And they're very specific about how it's written. If you look at the notation here, f of g of x is where this h came from, which means, was g plugged into f or was f plugged into g? G was plugged into f. So now your job is to write two functions, a function g and a function f. And again, there's lots of different answers to these, where if I plug g into f, h is going to be my answer. And again, on MathXL, one of these will be given to you already. You'll just be finding the other one. So there'll only be one right answer. Let me give you an example. If my f was the absolute value of x, just our parent function absolute value, g could be 3x plus 2. And if I plug 3x plus 2 in for that x, I get h. Make sense? Here's another way it could be written. F of x could be the absolute value of x plus 2. G of x could just be then 3x. Again, do you see how if I plug g into f, I would have that answer? So lots of different ways that you can do these. All right, try the 2 at the bottom with somebody near you. Try to find a way that you can plug a G into an F and get this answer. Go ahead. Couple ways to do it. Again, these are not the only correct answer. So you could make G x minus 4 and make F 5 over x is one way to do it. You could make G that whole quadratic, and you could make F the 4th root would work. Anybody have a different answer for the middle one that you would like to share? No. What about the bottom one? Anything different? No, we all did these. We're all on the same wavelength with each other. Okay, that's good too. I'll take it. All right, this Math XL is due on the 13th, which is next Wednesday. 2-9 will also be due that day. So those are going to be the last 2 sections in this chapter. All right, I have a paper for you. This paper is our warm-up tomorrow. I will check it when you come into class tomorrow for completion. So you have 15 minutes now to work, or you can complete it at home. It is an exit ticket / warm-up for what our lesson just was. Okay, so just a little extra practice. If you guys want to take the next 15 minutes to work on it together, great. If you prefer to work on your Math XL right now, that's great. I prefer some sort of math being happening in the next 15 minutes in class, okay? And then if you do not complete this in class today, make sure you finish it tonight, because when you walk in tomorrow, I'm going to come around and I'm going to make sure we all got all of our work and answers to these, and we're going to go through them together first off tomorrow. Right? It is for points. Yes. All right, so you can go ahead and get started on that. I'll do the cell phone lotto, or you can work on your Math XL. Those are your 2 choices right now. Let me get rid of this.